This is the brief on surface force calculations for two equal charges. Okay, so we're diving into a neat physics problem. Imagine two identical charges, right? Both Q, sitting 2D apart. We're going to see how the field between them actually pushes and pulls on a surface right in the middle. It shows how field forces work locally. First, let's look at the electric field, vec E, right on that central plane. Let's call it x3 equals 0. Because those charges are identical, guess what? The up and down parts of their fields cancel each other out perfectly. So the total field is purely radial, spreading outwards. This means the component along the line connecting the charges, E3, is just 0, flat. Second, this 0 E3 component changes everything for calculating the force on that surface using something called the Maxwell stress tensor. Turns out the force element, dF, just depends on minus the field strength squared, like minus 1/2 epsilon 0 E2. What does that mean? Well, it means the force is attractive, pulling inward towards the center in the minus vector E3 direction. It's like a tension across that middle surface. Finally, when you actually calculate the total force across that surface, you get exactly F equals minus Q squared over 4 pi epsilon 0 2D squared vec E3. Now, this attractive force perfectly balances the repulsive Coulomb force you'd normally expect between the two charges. It all adds up. The total force on the field has to be 0 for things to stay put. Static equilibrium. So this calculation really shows the electromagnetic field isn't just empty space, it's a real medium, holding tension to balance out those static forces.